So let's continue our discussion of fatty acids. I want to introduce the concept of the stability of the fatty acids. In chemistry, when we're talking about stability of a molecule, it relates to how reactive it might be. Fatty acids with double bonds are extremely reactive and can become damaged when exposed to heat, light, and oxygen. Damaged fats are rancid. Basically, when fatty acids bond with oxygen, they become oxidized, and this is not good for from a health point of view. Other fatty acids can be altered by a chemical process called hydrogenation, and I'll discuss that in just a moment. So why do we care? We want to make sure that when we're consuming fat, that we're not consuming any damaged fats. And unfortunately, there are numerous opportunities in our processed foods where fats are being used because it's easier and cheaper to use these damaged fats than it is to use high quality fats. So processed oils, for instance, are made, anything that's oil has polyunsaturated fats in it. And those polyunsaturated fats are very sensitive to heat, light, and oxygen, like we just said, because they have lots of double bonds. And they're subject to going rancid much easier. So here's an example of what we see almost any day that you walk into your grocery store. There are numerous oils on the market that are in clear plastic. They're sitting out on the shelf. They're being exposed to light. As soon as you open them, they're exposed to oxygen. So these are very, very subject to going rancid, and I believe that they should be avoided, actually. So looking at the actual shape of the molecule, and we're still talking about unsaturated fatty acids that have these double bonds. So I want to introduce this concept of cis versus trans. So you will notice this, here's your chain of carbon atoms, and here is your double bond. And you'll notice that in a cis formation, which is what most naturally occurring unsaturated fatty acids are in this cis shape, you've got your double bond, and you've got your two hydrogen atoms on the same side of the molecule. And that's significant because hydrogen atoms have a very slight negative charge to them. And so you've got these two hydrogen atoms right next to each other and a big hole on the other side, essentially. These guys repel each other slightly because they both have the same negative charge, and that is enough to make a bend in the molecule. If you have more than one double bond, you have a lot of bends in your molecule, and that's what makes them more and more unsaturated. Okay, so that's the cis formation. Trans, and I know you've heard of trans fatty acids, is a fatty acid that has a double bond in nature like this, that's gone through a process that's caused this double bond to twist. And so you've got this twist at this particular double bond, and now your hydrogens are opposite each other, and there's no longer this repelling between the two hydrogens. So this tends to straighten out the molecule. And so hydrogenated oils may be omega-3s, they may be omega-6s, but they are trans, and they can become solid at room temperature. Think of this as a stick. If you've got a number of cis formation sticks, so they've got bends in them, and you try to pick up a pile of bendy sticks, you can only fit so many together. They don't pack together very well, and there's lots of space in between them, which is why oils that are in cis formation tend to be in oil form. Whereas a straight molecule like this, you can pack a whole lot together and you can hold a whole lot more sticks, and they are more densely packed together, which is why your saturated fatty acids, which have all the double bonds, they are straight molecules, but so are your trans molecules. They tend to be in a straight line, so you can pack them together. So this is the situation that you find with margarines. So let's just look at what happens. They call this a hydrogenation process. They can also, in addition to making this trans, twisting the molecule, they can also just add hydrogen atoms to this and cause make it become a saturated fatty acid. So let's look at how they do that. So partially hydrogenated oils and trans fats are changing liquid into solid, and that's by changing their cis formation into either a trans or a saturated situation. And the way they do that is they put a vat of oil in there and they add a catalyst, and nickel is usually what they use. So they're using a toxic metal to cause this reaction. And so history of margarine, I think you'll just find this kind of interesting. They developed this in World War II because there was a butter shortage, and my mother tells me that she remembers getting these packets of hydrogenated oils with a little yellow dye in it, and you had to knead the packet, and then you would end up with something that looked yellow. Well, after the war was over, they realized that margarine could do a lot of things that butter couldn't do, and one of the things that butter can't do is stay it's a natural product, so it goes bad after a period of time, whereas margarine, it's almost like a plastic, and it can stick around for a very long time, very stable. And this was good for manufactured foods because then it would increase the shelf life of whatever product they were using that particular margarine or hydrogenated oil in. And so here you have this picture, which is pretty horrible. These are ants. Anyway, the ants know better. They know that butter is real and that margarine is something to stay away from. So that is something that I feel strongly and say to all my nutrition patients, that if you're going to go with butter or margarine, go with butter. Okay, saturated fatty acids are very stable for the same reason that the trans were, because they are straight lines and straight molecules, and they don't have the same reactivity. Sorry, I'm making a mess here. To heat, light, and oxygen. So in fact, I often ask my nutrition clients to use saturated fatty acids when they're cooking, because they're much more able to withstand heat. This is a lard substitute. It's not real lard, and it's also Crisco. A lot of people use it. It's all vegetable shortening, and that this is 100% hydrogenated oil. So I warn you against Crisco. All right, that's all I want to put into this particular video.